Welcome to the second of our two-day National Peer Exchange entitled Paving the Way, the Future of a Technologically Connected Multimodal Transportation System. This webinar is co-hosted by the Federal Highway Administration and the Utah Department of Transportation. It is focused on the literal and figurative intersection of innovative transportation technologies. My name is Muriel Xochimil, and I will be helping to MC this event. Multimodal transportation systems are becoming more advanced, with innovative transportation technologies set to revolutionize the industry within the next decade. Technologies such as connected automated vehicles, unmanned aerial systems, and advanced air mobility are part of a fast-growing multi-billion-dollar industry that will revolutionize how people and goods move across the country and the world. These technologies possess significant potential to reduce travel times, advance the goal of zero fatalities, expand throughputs, enhance quality of life, and improve the efficiency of all of our transportation systems. We have private sector representatives participating in our event. And while that is the case, and we welcome their participation, I do just need to add that UDOT and FHWA do not specifically endorse any company or product. UDOT and FHWA have assembled an impressive lineup of national subject matter experts, and we look forward to hearing from them soon. First off, we will hear from a panel of advanced air mobility professionals, both in the public and private sectors. They will focus on talking about specific AAM projects that they're actively working on and what's really taking off. I'll go ahead now and kick it to our moderator for this session, the Director of Aerial Innovation for WSP, Paul Wheeler. Looks like Paul is still logging in with us this morning, so we'll go ahead and introduce our panelists.
I'm here now, Muriel. Yeah, sorry about that.
That's okay, go for it, Paul.
Yeah, I just needed promoted as a panelist. So anyway, welcome everybody. Exciting for today. Let me go ahead and get my screen shared and actually get our panelist up here on the screen, unless you have that up, Muriel.
We have it up.
Yeah, perfect. All right. Perfect. We have an exciting array of experts today that you're going to be hearing from. Let me start off. I'll introduce all of them this morning in order, and then we'll have them do their presentations instead of doing one before each one. So let me start with Jared Esselman. Jared is the Director of Aeronautics for the Utah Department of Transportation. And Jared Esselman serves for the state of Utah, overseeing the statewide aviation transportation system. In this capacity, Jared manages the rules and regulations for aviation in the state and establishes the capital improvement program for all 46 of Utah's public use airports, as well as the management of the state aircraft fleet. He also serves on the board of directors for the National Association of State Aviation Officials and is chairman of the board for the Center of Aviation Research and Education. Previously, Jared was a director of state government affairs at the Aircraft Owners and Pilots Association. Jared has personally drafted and passed aviation legislation in 25 states. Really excited to hear from Jared. And next on our lineup is Adrian Lindgren. She's the Senior Manager of Global Partnerships for Hyundai AAM. So Adrienne is the urban planner and economic development professional with a focus on integrating advanced transportation technology into the built environment to enhance urban and regional mobility outcomes. As Hyundai Urban Air Mobility's lead for state and local partnerships, Adrienne partners with entities across the globe to better understand how urban air mobility technology can deliver universal, affordable, and human-centered cities, while driving and supporting initiatives that increase capacity for UAM solutions in a multimodal environment. Her work is guided by principles of equity, accessibility, and ecologically and fiscal sustainability. Excited to have Adrienne with us. And next, we have Emilien Marchand. Emilien leads Wisk ecosystem partnership efforts, including state and city engagement. Emilien led the U.S. public policy strategy for the Airbus Urban Mobility Division after holding partnerships and scouting roles at Airbus A3. He started his career as a rocket propulsion engineer after graduating with a Master's of Engineering in Aerospace from ISAE SuperAero and a Master of Science in Space Systems Engineering from TU Delft. exciting SMEs we have here today. Real excited to hear from them. And then after we get the presentations, we're going to have amazing conversation around some of these questions. So if you do have questions as we go along, please post those in our Q&A and we'll be able to get those to you and see if we can answer those questions that you may have. Take advantage of this. We have these experts here, so really take advantage of what you can and have access to them. And with that, I'm going to turn the time over to Jared to start his presentation.
Well, thank you, Paul. I appreciate that. And good morning, everyone. I'm thrilled to be here working on urban air mobility, talking about urban air mobility and sharing what Utah's done in this sector and trying to share some of our best practices, some of the ways we've been thinking about this with y'all. And I'm excited to hear from Adrian and Emilien as well from the industry side. Now, I do want to start, before I open up my presentation, I do want to say, you know, from a DOT standpoint, from a Division of Aeronautics standpoint, it's interesting and even sexy to watch the vehicles evolve, right, through this certification process and see what vehicles are coming out onto the market, or at least concepts. But for us at a DOT level, we look at those and say, what kind of system does it require me to build so that that vehicle can operate in my state? What do I need to do to be ready for that vehicle to operate safely in my state? So with that, let me kick off my presentation here. I'm going to share my screen. And Paul, can you see that all right?
Yeah, it's looking great and your audio is loud and clear.
Fantastic. Thank you, buddy. Okay, so let's just kick through this. So what exactly are we talking about today? Well, we're talking about advanced air mobility, which covers urban air mobility, electric regional mobility, and package delivery. And I've got just a few examples up here. I just threw some pictures up for the industry partners on the panel with me. If it's not yours, I apologize. I just got some. But this is exactly what we want to talk about, right? This is the big picture. The aerial taxis, the package delivery, and then electric aircraft in a regional commuter capacity. So what has Utah done? And I want to talk about not concepts, not how we thought about it. That happened 3 years ago. I want to talk about what we've done. So today, Senate Bill 218, which was passed in our last legislative session, instructed the Division of Aeronautics to put out an RFP for a study on urban air mobility infrastructure. That is currently advertised. So anybody listening today, if you're interested in proposing on that RFP, I can send you a link after this. You can shoot me an email. I'd be happy to show you where that RFP is advertised. So we do have that out. We also have, through our research and development division here at UDOT, which is called UTRAC, we have several UTRAC research projects, one on aerial corridor planning, one on vertiport location optimization, and one on the electrification of airports. Now I'm going to talk about these backwards in that list. We're not going to go in order because I think it's important to look at these in the order they'll come. So I want to do that. So let's talk about electric regional mobility. So if you have electric aircraft, you have to have electric airports, right? Ford could have built all the cars in the world, but if we never built a road, they'd all be four-wheel drive and off-road vehicles, right? You have to have, if you have an electric aircraft, you need an electric airport. And two things come to mind. One, can the airport generate the power capacity that's required, and how much power is required? And two, we talk about alternative refueling. So right now, our aviation system is paid for by an aviation fuel tax, but that's a liquid fuel tax. It is not currently an electric, quote unquote, electric fuel tax. So that is actually one of the things that we're taking into consideration in our UTRAC project is, how do we continue to pay for an aviation system when you're introducing an electric component? And how do those mix, and how do we continue to fund the infrastructure? We're developing a full plan for the electrification of our airports here in Utah. We're doing that through a UTRAC project. We've also submitted an application for an FAA grant. Primarily, that's for cleaning environment, a clean environment grant. But an electric aircraft is really we see it as the optimal way of providing a decrease in the carbon emissions around an airport. So here's our roadmap. We're really first looking at kind of that low-hanging fruit, trainer aircraft. We've got 3 major universities in Utah: Utah State University in Logan, Utah Valley University in Provo, and Southern Utah University, that all have significant trainer fleets. And we're looking at converting a portion of those into electric trainers. So we do believe that's the first step. And the reason that's the low-hanging fruit is we can get the STC. We have a company in Utah working on that STC with Utah State right now to actually make that happen. And that could very much be a reality in 21 or even in 22 if we don't make it in 21. We see cargo being next, cargo eVTOL, and then small airlines. The reason we put small airlines before the eVTOL or the urban air mobility is they don't need any infrastructure change. You're only changing the aircraft. You're not changing the infrastructure it utilizes. The airport stays the same. All the FAA regulations stay the same. We think that can become a reality prior to urban air mobility. Not to say that these aren't synergistic in an ecosystem, but we see that as needing fewer changes, being a lower hanging fruit, as it were, to the urban air mobility eVTOLs. So we're also, I wanted to show you this. This is kind of a picture of, if we break those phases down for you, the yellow, this is a map of Utah, and the dots are our airports. And the yellow dots at the top, on the top layer, are our major universities. Those are the airports: Cedar City, Provo Municipal, and Logan Regional. And so those 3 airports have major universities. And these are the yellow arrows are their primary training tracks. They fly to St. George, they fly out to, not Duchesne, excuse me, Bryce Canyon, and Hurricane. And Provo and Heber and Spanish Fort and South Valley Regional, those are the primary places the primary routes that they fly their trainers. And so that's the first phase, the trainer aircraft. The second phase, the electric regional commuters, we see that easily being a St. George, Cedar City to Salt Lake, Bryce Canyon to Salt Lake, Moab to Salt Lake, Moab to Heber, Vernal to Salt Lake and back, Salt Lake to Logan, even Brigham City. This is where the urban-ish populations are, or a lot of the destinations in our state are. And we see, as we even count commuter traffic at UDOT today, we see this is the highest potential for profitable and regular small fin haul commuter airlines in electric aircraft. So that's phase 2. And then here are our urban clusters, right? Your Cedar City, St. George, Hurricane, and then your Moab, Green River, and then your Wasatch Front. Your Wasatch Front is clearly those several smaller rings and circles and routes. And this is where we see urban air mobility really becoming a bigger part of the picture. Now, these are still all airports, and we're still talking about airports. We haven't even discussed the inner city vertiports, airports within the city yet, but we see the airports as playing a major role in the advent of urban air mobility post electric regional commuter aircraft. So that would be phase 3. So let's talk about vertiports. Well, okay, we about the airports. Now let's get down to the nitty gritty of what Utah is doing to plan for vertiports and where they go in the city. So one of our UTRAC projects is actually developing a series of criteria which we can then judge and use for land use planning. So the map on the left here, this is the Wasatch Front. The map on the left, the blue, is everywhere you could put a vertiport. That doesn't mean you should, it's just everywhere that is possible. The map on the right then prioritizes some of those elements, those critical elements, and we put it on a scale of, hey, green is, this is high potential for a good location for a vertiport. And then the other end of the spectrum is red, where this is probably not somewhere where you would want to put a vertiport. I'll give you a little close up of the optimization maps here. So if you can see, this is, there we go. This is over in Cottonwood Heights, over by Sandy. This is just kind of a close up of that area. You can see the blue everywhere that it could go. And now you can really see the city blocks and the differences and the separation of the roads. And then on the right, you can see there are some city blocks we just don't want to put a vertiport. And there are some city blocks where, hey, this would be pretty perfect. And we do have our team, our research team is working on different criteria elements, right? What's important? Is it a park? Do you really want to put a vertiport in a park? Is it a school? You definitely don't want to put one in a school. So what are those different elements and how do you rate them? So that UTRAC project is actually wrapping up and should be done in the early spring of 22. So once we talk about, okay, we talk about where we put vertiports, but when you're talking about the ecosystem, when you're speaking systemically, we began with the end in mind. And we started this about 4 years ago thinking, okay, how do we actually make this reality? And we talked about digitizing, fully digitizing the airspace. And so the map on the right, you can see the different counties and different volumes of airspace that we considered. And as we consider it, we look at the FAA, and we've been talking with the FAA on active management of airspace versus passive management of airspace. Now, the FAA says that they manage all airspace from the blade of grass to the moon. And technically, they're correct. But there's a difference. Class B airspace, the big airspace around large airports, is actively managed with an air traffic control tower. So for us, that includes Salt Lake International, Provo Airport, and Ogden Airport. Those are the airspaces within this map that are actively managed by a controller. Outside of those, it is only passively managed by rules and regulations that the FAA has put in place. But if this is to work, if urban air mobility is to function safely, it has to be actively managed. And we're going to have to see everything that happens in that airspace and know everything that happens in that airspace and be able to manage the aircraft in that airspace. So this ecosystem is going to require new infrastructure. It's going to require both hardware and software. So here are some of the components that we have seen both the industry and government say, yep, this is what we need. This is what's going to work. This is not set in stone. There may be new evolving technologies that come forth. Great, that's wonderful. This is what we've seen that we have and that we need. So on the left are all components that we have. So radar, Fordham Technologies is a company that produces radar right here in Mount Pleasant, South Carolina, Pleasant Grove, Utah. So we have the radar. We have a GPS RTK system. Matter of fact, our moderator, Paul, was one of the people who helped put that in, him and Sean Fernandez. It is a global positioning system, real-time kinetic system that gets surveyors within a centimeter accuracy of what they're looking for. And we're hoping to be able to use that system, and not just hoping, we are planning to be able to use that system to track aircraft. We have a powder project. Salt Lake City and the University of Utah were one of 5G, true 5G, not the T-Mobile 5G advertisements that you see on the television or hear on the radio, but true 5G. They're one of the 5G test beds, Salt Lake City and the University of Utah. So they call it the Powder Project, and we've been working with them on how that very low latency system could be utilized for our infrastructure needs. Weather. Now we have AWAS systems at airports. We have weather reporting in different places across the city. UDOT actually has a micro weather grid where we put weather sensors all over our road system, and we can tell you what the weather is in a very specific spot. And we're going to need that, especially for vertiports, and we're going to need to know, and urban canyons, right, in between buildings. We're going to need to know, how do buildings affect the weather patterns across our entire valley? How do different how does one canyon's weather different from another canyon's weather? Because then on the Wasatch Front, we have multiple mountain canyons, and we have to know each one is different. You can't just have one big weather outlet. You have to know on a micro scale what the weather is like. With the GAP Labs at the University of Utah, we built a traffic simulator. We built something to test thresholds. How many vehicles can you put in the sky at one time? What's the separation distance threshold? How do you test that? How many vehicles can you fit and not break that minimum separation distance threshold? What if you change the speed limit? What if there are 100 vertiports? What happens when you add the 101st? What if there are 1,000 vehicles? What happens when you add the 1,001st? So we built a simulator to kind of test all that out for us. And then we have a UTRAC project that is planning aerial corridors. Not just planning where they go, but planning energy consumption and package delivery and time in the air and the number of delivery trucks that would remove from the road. So we're working on figuring out all of those elements. I'll show you that just here in a little bit. The things we need: delegated authority. The FAA still holds that authority. Technically, we don't have the authority to manage the airspace. They do. But we would like to do that hand in hand with them. It's yesterday, Michael Huerta in our keynote session mentioned the FAA may not have the capacity to do it. They may not want to do it. So we do need to share that authority, or at least be delegated some authority, so that we're doing that hand in hand. That precedes a central coordination or an air traffic operations center, some kind of command center, a UTM, which is the software infrastructure that we will need to make all this happen. We'll need to be able to give flight clearances. We still are working on our regs and our regulations and standards. We've been adding a little bit of law to the code, to the Utah State Code every year, just as we learn what's evolving. We're working on land use planning and urban planners and how they see vertiports fitting into the city, and how glide slopes and airspace slopes work in an urban environment. And then permitting, right? Are we permitting the vertiports? Are we licensing those? Are we registering the aircraft? Are we licensing those as well? How does that work? So we're looking at all those things. Those are things we still need, but we do have some components in the infrastructure. Matter of fact, that's what our RFP is looking at. What do we have? What do we need? And how do we bridge that gap? So I wanted to show you a little bit of the product of one of our UTRAC projects. This is for package delivery drones, and these are straight lines. We know that straight lines may not always work. It is the shortest point. It is the shortest distance between 2 points, but it may not always work in this particular ecosystem. But for testing purposes, we're looking at kind of a hub spoke model for package delivery drones. And if there was a hub spoke model, what would that look like? So this is just a rendering out of one of our simulations. So I shouldn't use the word rendering. It's actually one of our simulations, just a screenshot from it. And it can tell us information on different energy usage, right? How much energy are these drones going to use if they're flying these distances at these times for this long, carrying this amount of weight? What kind of recharge capacity do they have, and how much power will they need? We can tell how much power they'll need by determining how much energy they're using. And round trip time distribution, right? So how much time does it take to make this round trip? I'm going to drop this package off, I'm going to come back. How much time did I spend in the air? If I drop the package off, now my weight has changed. Am I coming back faster? Am I getting there slower? What's that difference? And also one that's not shown here that is probably my favorite is, if I'm delivering this number of packages through the air, how many trucks did not have to be on the road? And that's another one of the metrics that we're actually testing here in Utah. So I wanted to show you all this because this is not conceptual. This is not how we're thinking about it. We're actually doing this. And I say that humbly because I know that there are states who have invested millions, tens of millions of dollars into making urban air mobility a reality. Utah is very fiscally conservative. To date, we've got about $300,000 into this, but we've still come a long way in the planning process and the planning and design. The current RFP will hopefully take us to the next step of a construction RFP, designing, engineering, and then putting this in the ground, putting the hardware in the ground. But as I kind of promote what we're doing, I just want to acknowledge, what other folks are doing as well. This is the best practices from Utah. This is how we're thinking about it. I do appreciate hearing what North Carolina and Ohio and North Dakota and New York and Nevada have done as well. And some of them, I think, yeah, we're on right tracks. We're making mistakes in some places, but you know what? That's okay. This is a brand new system. We have to be okay making a few mistakes, learning a few lessons here and there. In the end, the return on investment is what you invest into it. But I feel like as the director of aeronautics that we are on the right path here in Utah. We're thinking about this very smartly. We're being very fiscally conscious about this. We're trying to time our investment in infrastructure with the alignment of supply and demand that will make itself available in the urban air mobility market. If we get ahead of the market, well, then we have roads with nobody to drive on, essentially, right? We have aerial corridors with nobody to fly through them. If we're behind the market, we're trying to catch up. We don't want to play that game either, but we want to be right on time. And I think we're making pretty good progress on that parallel venture. So with that, Paul, I know we'll take questions at the end and I'll turn it back over to you.
Perfect. Thanks, Jared. Exciting to see what you've been working on and all the projects. Real exciting for what's happening in Utah and across the nation with advanced air mobility. And with that, let's turn over to Adrienne and hear what Hyundai's doing.
Hey, Paul, can you hear and see me okay?
I can hear you. I cannot see you yet. There we go. Perfect.
Let me get my screen shared here real quick. And all right. And can you see my screen?
Yeah, I think it's just delayed just a second here. Let's see, it looks like I've got your presenter side rather than the other side of your, you might want to share your other screen.
Hold on one second. Let me check here. Okay.
There we go. Looking great.
All right, great. Well, hey everyone, thanks so much for having me today, Paul, and FHWA and UDOT. Really excited to be part of this forum. I'm Adrian Lindgren. I'm part of our Urban Air Mobility Division of Hyundai Motor Group, and I lead our state and local partnerships, as Paul pointed out. I have been with the team for just over a year, and my charge is really to help partner with cities to develop the market in a way that really envisions AAM as part of this intermodal and multimodal ecosystem, whether that's utilization of our vehicles or public transportation networks. We're very focused on really powering human-centered cities through the investment and deployment of a suite of multimodal and e-mobility innovation, ranging from sort of the vehicles you see here to the infrastructure itself. As part of the Urban Air Mobility Division, I'll talk a little bit about the types of aircraft we're working on, but this is really, our sort of future forward perspective on how we need to invest in both air and ground vehicles in order to come together to bring the appropriate infrastructure that can support a suite of different types of vehicles, whether or not they're Hyundai vehicles or others. I like to sometimes give a little bit of background because when I joined Hyundai Motor Group, I did not necessarily know how we ended up becoming aircraft OEM. But basically, Hyundai actually started as a transportation infrastructure company in post-war era in the 40s. And it wasn't actually until the 60s that we started expanding into vehicles. And really over the following 40 years, we became known for our vehicle reliability, affordability, our warranty and maintenance programs. And as we look towards the present, we have really focused on transitioning from a kind of traditional auto OEM on the vehicle side towards a more comprehensive mobility solutions provider. And so we've made a number of investments, I'm sure you may have heard of, across Motional, Boston Dynamics, Motion Lab, a whole host of different types of organizations that are either focused on the development of ownership-based vehicle models or a very different type of ownership model where you are supplementing with a different ownership structure and a different type of business model. And we really see urban air mobility as part of that comprehensive investment in both ground and air mobility to bring together what is really more human-centered cities that are focused on really building around people versus thinking about just shoving people into the vehicles as we sort of traditionally have. We're making a long-term commitment in this space, committed about $1.5 billion over the next 10 years. And again, we're very focused on that, building human-centered cities that really leverage innovative mobility solutions and all of the technology advancements that we're seeing that enable these different types of innovative solutions to be delivered, really with the goal of providing affordable and universal mobility service options. So that's kind of a constant theme that you'll see throughout the different types of acquisitions that we make and the different partnerships that we make. Is how do we really approach mobility from the standpoint of anyone and everyone should have access to it, and how do we play most effectively to support that type of an ecosystem? We really see three fundamental air mobility markets ourselves. So there's urban air mobility. We're thinking a little bit more, we kind of think about this, three of these as part of the advanced air mobility market, which we know includes drones, some others. But for our purposes, we're very focused on an urban air mobility vehicle, slightly less range than something like a RAM vehicle, regional air mobility. That's going to be somewhere between 60 and 80 miles, carrying 4 to 5 people. That'll be initially piloted and then converted to autonomy, really when it's ready. We're starting off with electric, but very much looking towards all of our design to be adaptable for hydrogen and alternative energy as it comes onto the marketplace and as technology advances. We're also developing a regional air mobility vehicle that's going to be focused more on that 1,000-mile to 1,500-mile trip, really filling some of the gap that we have in certain regions where it is particularly cost prohibitive, both for urban air mobility vehicles and regional air mobility vehicles, to build ground-based alternatives. And then we also are focused on a medium cargo. So this is something around 500 kilograms to 1,000 kilograms. And we are developing that vehicle out of Korea. There's substantial coordination that's pretty exciting between both our Korean teams and our US teams on the development of all these platforms. Our fundamental mission within urban air mobility, which I'll speak to in a little bit more depth now, is to connect communities and save passengers' time at a very kind of simple level. We want to develop vehicles that are first and foremost safe, but quiet, affordable, and again, seamless in the intermodal journey. We also are very focused on partnering across the ecosystem to invest in off-vehicle aspects of the ecosystem, from infrastructure, developing proactive regulation and policy, and really collaborating across industry and government partners to push public acceptance in a way that I think speaks to and reaches the public of where they're at and finds unique ways that AAM can contribute to people's lives versus being seen as either a nuisance or just another service that we've sort of thrown onto the market. We really see, I've kind of harped on this, but I think a big North Star for us is that multimodal and seamless journey. And we think that there's a real opportunity here to combine what we have in expertise on ground mobility by investing in the air side. And this sort of gives you a little bit of a roadmap as to how we think about the customer journey. As you can see, there's a lot of integration that's going here between ground, air, different types of software and hardware. And so we're really trying to take a comprehensive approach to the ecosystem because we obviously aren't going to own everything here. And so partnerships are a very fundamental aspect of our objectives in pushing AAM. Sort of the ecosystem, I think the hardest part about AAM, and I think the hardest part about a lot of mobility innovation that works across a few different types of verticals in this space, is a and integration of all of these different systems together. So we obviously see certain key locations for infrastructure, but I think really the North Star here is to get to what you can kind of see as an image on the right, where AAM is a part of a transit network. It touches public services and private mobility services alike, and does not necessarily operate in a silo, which aviation and ground transportation have sort of traditionally operated slightly more separately. We sort of think the way to do that is to scale UAM in phases. Admittedly, we're a later entry vehicle, so we're targeting the end of the 2020s. We really see, however, an opportunity to lay the foundations by working across with other OEMs, with other parts of the ecosystem, and with other public and private partners to set up what we see as sort of testing and demonstration facilities, targeting really airports, right, existing airfields, moving to that market development phase where we actually start seeing initial operational sites and revenue generating use cases online. Also using some of those proof points from airports to make a better case for how blended investment can come together to help scale towards network expansion. And we sort of look at network expansion as this opportunity to integrate airports, commercial property, multimodal institutions, and bring them together towards really a full network. We sort of layer these in order of complexity. I think in many ways, it's hard for people to envision an AAM vehicle taking off from a train station when they haven't ever seen it take off from an airport. So try and think about how do we sort of work through each of these partnerships to move through different stages of capability of maturity while building capacity during each of these phases across stakeholders. To do this and sort of take a step back and how do we make that a reality, we're really focused on confronting the challenges and concerns, especially that our city stakeholders here in enabling the UAM market. I think we hear a number of different worries in general by AAM. A lot of them are underpinned by public acceptance, but funding, conflicting timelines, roles and responsibilities and regulations, demand, these all come together to sort of self-reinforce each other. And I think we try and chip away at each of these different questions while thinking about their relationship to one another. We do believe that there is a lot to be gained from the deployment of AAM, especially within that sort of intermodal context, whether that's increasing capacity of the network, increasing land use efficiency and asset utilization, or reducing emissions, congestion, and infrastructure costs or lost time. Again, I think we don't want to talk about AAM just in the silo of what it provides, but how does it work within the network of a number of other types of modalities to provide efficiencies and optimization to the built environment. When we think about where some of the gaps that we focus on is through these conversations, public engagement with different public, both sector stakeholders and communities that we seek to serve, I think we see four real areas where I have particularly focused. One is really understanding what that clear pathway is for infrastructure development, how we can work together both on the industry side and the public side to create sort of standardized and interoperable infrastructure. Public awareness, capacity building, and consumer acceptance. The number of people who have ridden in a small aircraft in their life, who use that as a primary mode of transportation is relatively small. And I think the burden is on us and the opportunity is on us to increase communication and make sure that we're bringing people into aviation as a household name as we try to democratize it and make it a more affordable and universal service to folks. Thirdly, I would say clarity on multi-jurisdictional governance and coordination. Jared did a great job talking about a number of these different areas. I think he covered this topic really, really well. But since I got into this space in 2018, there's certainly been, I think, much to be desired in understanding exactly who's doing what in this value chain and how everyone comes together to make it come to fruition. And then finally, and I won't stress this one because we've talked about it a lot, but what does that roadmap look like for intermodal integration? Again, I think intermodality and multimodal integration is something that, especially as we've seen the proliferation of private transportation services over the last 5 to 10 years, it is a North Star that we all sort of struggle to get towards. And I think we have a really interesting opportunity, and we see the energy on both the public and the private sector side to really collaborate towards thinking, okay, how do we take all of these different types of innovations and produce a better, more effective and optimized built environment? So I'll pause a little bit to say, what does success look like to us, thinking about some of those challenges that we just talked about, so the key North Star elements that we're trying to move towards. To me, in the really immediate objective, and we'll talk a little bit about proof points of where we're doing this, it's inclusively engaging the public, demonstrating, people can't understand what they can't look, touch, feel, and hear. So how do we bring that to them even before potentially an aircraft is available for them? How do we provide tools that help build capacity for cities and for people to understand the opportunity and also some of the challenges and mitigating factors that can be introduced for urban air mobility? And how do we help proliferate those so that we reduce the overall burden on any one city, state, et cetera, to take on this new and exciting realm? And I think this is, for example, a really great forum FHWA is running that is very focused, right, on kind of distributing those best practices that Jared talked about, what they're doing at UDOT. There's a lot of different proof points you can look at around the country and around the globe. I think there's a really interesting opportunity to bring those together and understand sort of what works, what doesn't, what is maybe locally sensitive or different from place to place, and what maybe can be standardized and what can we borrow from one another. There's also, I think, that focusing on those two areas will allow us to really create meaningful enabling policy, allow us to model demand and really simulate impacts so that we can articulate to people both what the transit level impacts or transportation network level impacts of a scaled AAM network look like, but also what site level impacts look like, and hopefully give us a baseline to work from so that as we start to deploy vehicles, we can test and measure impacts against those and continuously improve the service and understand what the challenges are and how they relate to our assumptions. We definitely know that it will take a village to enable a competitive market. So we're looking to work, like I said, across the ecosystem within AAM. We are also looking to work across the mobility ecosystem. So again, how do we get towards that optimized, efficient, and affordable mobility network? I think it's really by working to think that micromobility, ferries, taxis, hydrogen fuel cell, heavy duty, all of these things come together, right, to create a better mobility ecosystem and network. And we really see advanced mobility as just one component of that. How we plan to do it, and we'll talk a little bit about proof points after this. Again, we're here and hopefully, and I'm particularly here, to empower cities and states to enable the human-centered mobility marketplace that should include AAM. We really believe that driving collaboration, focusing on capturing transportation's true benefits, and being both economically and environmentally sustainable are some of the methods that are going to help us get to those sort of outcomes on the right that you're seeing that we're really trying to drive towards. Talk a little bit about a couple of case studies of how we're working across the ecosystem, across different partners. So this is a project we're doing in Coventry in the UK. It's an hour and a half outside of London. We partner with Urban Airports, which is an infrastructure development company. You see their Air 1 in the middle there. This is a program that is part of the UK Future Flight Challenge. So this was a sort of matched grant opportunity. And really the basis here and the goal is to be able to demonstrate the infrastructure, the ground-based infrastructure that would support AAM and other vehicles, other types of services and activities, and really bring it to people so they can get that look, touch, and feel. And at the same time, work across these different partners to understand how the infrastructure can complement the existing activities, existing environment that's currently being deployed and currently being utilized, where again, can we add value versus just adding another service onto the road. I think another really interesting project that we have really enjoyed working on is part of the Canadian Advanced Air Mobility Consortium. We have been helping really spearhead the National Master Plan and really trying to ask ourselves, how do we create a guiding framework both at the city and the national level that actually that leverages the work that's already being done, right? There's a lot of incredible work that's already being done both at national, regional, and city levels to advance transportation innovation, electrification, sustainable mobility. And I think we're constantly trying to find exercises that push us to say, how do we be valuable to both federal regulators and cities? And how could people potentially find the work that we do useful in integrating into their own work? Again, we don't want to reinvent the wheel, right? We want to understand how do we complement what is already happening. And I think that's in many ways where AAM gets the best messaging and resonates most, right? Is by nesting it within those things that people are already doing. And then finally, talk a little bit about the Los Angeles UAM Partnership. You guys heard from Clinton Harper earlier in this event, and we've been very excited to support the really interesting sort of leading work that LA is doing to socialize and visualize UAM through bespoke public engagement strategies, help understand what those strategies look like when it comes to implementation, really support the development of technical processes and policies, and also help provide the different types of collateral and visualization material that's going to help them speak to their message. And how do we sort of, as OEMs and as people who work across multiple cities, how do we think about taking some of those resources and best practices again and helping shop them around, vet, validate, and replicate them in other places? And I think, for us, we're always sort of focused on that. How do we build capacity at multiple levels while helping promote some of the standardization, interoperability that we really believe is going to be foundational for making this market come to fruition in sort of the scale that we're hoping to see or envisioning. And I'll end there. I know we have questions at the end, and I'll turn it back over to Paul. But thanks again for the opportunity and looking forward to the Q&A.
Thanks, Adrian. Really good insight, and love the roadmap and the approach that you're taking for this. Really appreciate you being here, and really excited for our discussion that's going to be coming. And next, we got Emilien. He's going to talk to us about what Wisk is doing.
Hey, Paul, can you hear me well?
Yeah, I can hear you great. Seeing your video now.
What a great radio voice you have, by the way. I felt like I'm in an airplane listening to ATC right now.
Perfect.
Right.
All right, I can see your screen. It's looking good.
You can see my screen. All right,
yeah.
Great. So yeah, thanks for the opportunity to speak today and to the Federal Highway Administration and UDOT. I'm going to try to be, a little bit short so that we have ample time for discussion, and there's a lot of great points that the two previous presenters, Jared and Adrienne, have brought up. So yeah, I'm excited to speak to you guys about Wisk. Wisk is a company based in California, and we also have operations in Atlanta and New Zealand, and that especially the New Zealand part is pretty important, and I'll speak to it later. Briefly, here at the beginning, let me minimize this. Why? I mean, what we do this, I think it's been pretty obvious over the last few years that more and more the ground infrastructure and the way we the solutions that we have for mobility today are reaching a tipping point, and the infrastructure supporting it is not enough with the growth that we're going to see over the next decade. And so we need new solutions. And we feel like advanced air mobility is one of these solutions that city and regions are going to be able to put in their toolbox. And when thinking about this multimodal approach of mobility, use this in order to enhance the livability and the economic development of their city and the traffic congestion, hopefully. But it started with this already many years ago. But the more we think about this industry and develop this industry, we think of opportunities of how to connect people, how it will connect places and goods, create new jobs, support local economies, also be a spark for sustainable transport in the aviation space. I think advanced air mobility really has spearheaded electrification in aviation, and this is pretty fantastic. And also, use cases of helping people reaching hard to reach areas in situation that could pose a risk for human life. So lots and lots of use cases that are still not all defined yet, and still a lot of work to do. Why now? The technology finally is getting ready. The battery technology, commoditization of electric motors, and so now that the technology is ready or close to ready for advanced air mobility, that's when we need to start the work on understanding the regulation, doing the city integration process, and all these things, planning and development. They take a lot of time, and I feel like I used to go to conferences where a lot of people would focus on the technology issues to solve, saying public acceptance and city integration will be solved down the road. We'll do that. And I always saw it the other way around, where I think we have brilliant engineers worldwide. Technical problems are going to get solved, but all of this city integration work, policy, framework work, and so on is incompressible. And if you don't start now, years ahead of the entry into service, you'll have to do it down the road. So that's what we focus on at Wisk for now, on top of the aircraft development. Our mission, simple, like Adrienne had a simple mission. We want to deliver safe everyday flight for everyone, not just the uber rich, but really everyday travel for a class of people, and doing that safely. Pretty forward, straight to the point. A little bit about us, where we are today. We have about 360 employees, as I mentioned, 3 locations, the main ones in the Bay Area and New Zealand. Many patents issues, over all the generations of our aircrafts. We had over 1,500 plus hours at full scale. And I think what's important also to mention, and I'll go on it a bit later on partnerships, but we are the result of a joint venture between the Boeing company and Kitty Hawk. Kitty Hawk being the eVTOL company starting by Larry Page over 10 years ago in the Bay Area. Larry Page, the founder of Google. As I said, 10 plus years of flight. You see here all the generations of aircraft. The one you see Cora in yellow in the center picture is the generation 5. And we're currently working now on our generation 6 aircraft, which will be the one we'll push to certification and entry into service. And our focus in leadership is really in autonomy. We've been one of the few companies that made the decision to go to self-flying first approach since day one. I'll go a little bit more in detail on the why, but we really see this as a difference maker and something that is in line with the long-term strategy of advanced air mobility. A little bit more now on our generation 5 aircraft, Cora, who's the one that's been over the last three years really flight testing both in Hollister, California, and in New Zealand. Cora is 2-passenger, highly automated aircraft operating under supervision and direction of a remote pilot. It's been designed and manufactured for safety, redundant in batteries, propulsion, and avionics. Really reliable with a few moving parts. We have a parachute on this aircraft as well. A little bit about the aircraft itself so that you get a sense of what it is outside of the picture. So it's 21 feet long, 36 feet wingspan. We have 12 independent lift fans, and this aircraft, this test aircraft, has a range of 25 miles or 40 kilometers for the Europeans like me, or the Canadians, or I guess anywhere else in the world, but US and UK. And we go at 100 miles an hour at 1,500 to 500 feet AGL operating altitude. So really a great aircraft that has, allowed to make strides in self-flying, in gathering data that would be critical for the certification of a self-flying aircraft with the FAA and with the EASA. So I was mentioning a little bit before, why self-flying first? And there's been in the industry this, do we go for piloted, self-flying? There is no very straightforward path in certification today with either agency. We decided self-flying first because we know that's where the advanced air mobility industry is headed eventually. It improves safety and it's really key for the scalability of the system. I think when we talk about all these potential transportation changes that this industry can bring, it will do so if it reaches a certain scale. And so in order for that scale to be reached, autonomy is going to be critical. We, similar to Hyundai and Adrian, we're very environmentally conscious. When it comes to the aircraft, adopting life cycle engineering practices, ensuring the products and the materials that we use can be recycled or safely disposed without having a negative environmental impact. In our operations today, we are very conscious about our carbon footprint. In our test operations, obviously, we haven't started operations yet. But for example, we recycle battery packs for current aircraft to ensure they have a minimal impact on the environment. And really also when we do our infrastructure studies, we really make a point in making sure that we look from all these different angles: sustainable energy grid improvement, ensuring it's a small footprint, they're compact, multi-use types of infrastructure. So it's really front and center in our approach. A little bit about our partners. So I was mentioning we're backed by Boeing. This is not just a financial backing. This is also an extended arm that we have in terms of policy development, certification in autonomy. We, for example, are conducting a first transport trial as part of the New Zealand government's airspace integration trial program. So I was telling you that there's a special relationship we have with New Zealand is very important in this case, and in situ, a Boeing company is also supporting this effort. In addition, we are an AAM industry partner of NASA through their NC1 campaign. And Wisk also partnered with Blade and will provide 30 eVTOL aircraft to operate in the Blade network once we'll have a certified aircraft. Now I want to speak about something that we released recently that I think is a big differentiator for us and a testament for the approach that we've had over the years. Social acceptance in advanced air mobility white paper you can find on our website. And it's really the fruition of the key learning of the last 5 years in the New Zealand ecosystem. Having no real precedent in introducing such a multifaceted product or service, we have now this unprecedented opportunity to shape this new industry and ensure that it benefits all the members of the community it serves. And this, action of community engagement and achieving social license is a huge part of doing a good job in shaping that future. The way we define the way social license is defined, and there's a keyword there, is the ongoing acceptance or approval of an operation by those local and national stakeholders who are affected by it and who also affected success. And ongoing is crucial because it's going to take a few decades to really reach this worldwide scale that we talked about, and it's going to be very important from now as we're designing the systems and the infrastructure, but in the ongoing design of this industry, that we keep this ongoing acceptance and approval and social license. And being thoughtful on the early start really is what's going to help us design a system that's serve the environmental and societal needs in equal value as the economical benefit. So, really our understanding and what it took to integrate this in the US, Australia, and New Zealand, working with government, both central and state, but also, indigenous people and underrepresented voices in New Zealand specifically. So I hope you read this paper. It's really a testament on what it means as a city or as a region to partner with us in exploring what advanced air mobility can be. And some of our key principles in engagement, really obviously safety, maintain high level of consumer and public safety and security at all times, equitable and inclusive as we are charting this and our integration in regions and cities. We want to include diverse perspective in order to build and maintain trust and respect. I think it's very important accessibility, to be open to engagement, even for the questions that might be tough to have. We talked about social acceptance, noise, and et cetera, but really to hear everybody who's affected by the operation. And the last one, evidence-based. As Adrian was mentioning, when we model multimodal transportation, it's going to be key for cities that are going to be co-investing in those infrastructure to have the data in order to really understand what they're getting themselves into, and it has to be data-driven decision-making. And this is my last slide. I'll conclude on this. Obviously, we want to have a wide stakeholder mapping, have a comprehensive approach, not just with the voices that are seen to be the most important, but all the ones that matter. And that can be a much wider group that you might immediately think. Creating the dialogue early with the communities and really put access and inclusion front and center in our approach that we do. And after this, it's really about working with these communities and the stakeholders in the city to make these data-driven decisions on how advanced air mobility can really improve the mobility and livability and achieve their goals in a data-driven approach, quantify the economic benefits, and outline plans for social equity, job promotion, STEM education opportunities. As I said before, it really is a great opportunity we have to try to do things right in the way that in many other industries, it hasn't been done before. And so I'm glad that we have events like yours today in order to spread that message and make sure we're aligned on the right way to approach this industry, this new industry. Thank you very much.
Thanks, Emilien. Wonderful content. Boy, so much great stuff in this hour. I wish we could just have a whole day to talk about some of these areas. We're getting a little lower on time here, so I just want to commend everybody for this great stuff. Jared talking about how you don't have to have a lot of money or budgets to start planning, but start somewhere. And really, Adrian saying this is the North Star to guide the industry. I love that. And Emilien really focusing on social acceptance and how to do this is great things. I just got one quick question for the time that we have. So there's a lot of different states looking to get into this right now, and they really want to know and understand, how do they get involved? How can they connect with OEMs, and where should they start? If you guys could just quickly do a take on that.
if you want to start.
Go ahead, Emilien.
Yeah, sure. I mean, I was mentioning the social license paper. I think is a great way to see how the industry is approaching, public acceptance and the engagement with the public and the mindset that we have. And I think that as the industry is going to work with city and city integration, make sure you talk to your representatives. Various states, Jared was saying, are putting out RFPs or are going to putting legislation to evaluate the policy gaps and what needs to be done in order to thoughtfully incorporate advanced air mobility. Reach out to your representatives when these initiatives are put out. That's also their role to explain that to you, and that's our role in the industry to collaborate with the state and local authorities to share what we know and really do that hand in hand.
I'll keep it brief. I think that was a really great point from Emilien. I'll keep it brief by just saying I think that the best way in many, I've talked about intermodality to get to a really optimized and functional AAM system is to understand what the pain points are and what the objectives are. What are the aspirations of transportation planners, urban planners for their built environments and for their cities, so that we can work backwards. And I think there's data sharing. There's a number of different ways that can take shape. But I think if we can all focus on thinking about what we want to see overall in 10 years in these cities and work backwards to say, how does AAM contribute to meeting those objectives? That's going to be ideal. But we, that dialogue is really critical for us, and understanding what those objectives look like are really important to meeting that particular goal.
Anything to add there? Thanks, Adrian. I was talking lips for a sec, so I forgot to unmute. Do you have anything to quickly add, Jared?
No, Paul, I think
right.
That's great. What they've said covers it, and I'll just get ready for the next panel.
All right, perfect. Well, thanks, everybody. Again, we didn't get a lot of time to talk. We had some great content. If you want to reach out to them, their contact information is there, and please feel free to do that if you have some questions that weren't able to get answered. And I just want to thank everybody again for a wonderful session and panel.
Thank you all, Adrian, Paul, and Emilien and Jared. Talking about advanced air mobility is always really exciting.